In this exercise, we'll see how we can abuse some load balancer or proxy that transparently forward what they think are stream for WebSocket. We have this simple application here that has some WebSocket, but it's actually not important for the exploitation. So we won't need to communicate through the WebSocket channel, but first we need to trigger a few requests. So in the system status page, behind the scenes it's triggering those requests. So those requests are basically it's receiving one request, it's doing the request, and then it's returning its content along with the status code from the specific URL that was fetched. So it's not super realistic, but it's just to show you that based on small detail we can potentially abuse proxy. So here basically we have control over the status code here from this endpoint, and we are going to use this with a website that we control. So here host docker internal is the companion application that you need to have start at the same time as the application. It can also be started with Docker Compose. And this endpoint is just returning always status code 101 with simply the answer OK. And basically if I copy this URL to this lcheck endpoint, we'll see that it's actually returning status code here, so we can control this value here. And because we'll pass through the proxy, what will be following this GET request, because in WebSocket you usually have an upgrade header, with specifying to which protocol you want to upgrade, and if the server accept and say switch, what will follow in the byte stream will be the new protocol to which it has upgrade. But here because it's returning 101, the proxy in between the application and the client will think it's now doing WebSocket or any protocol, so they will forward every byte in the same stream. So we now have a direct communication with the server. But because we have this weak endpoint that can return any status code, we can abuse this and do a communication. There's no WebSocket that is established, and what will go on is just regular HTTP, but the proxy will think that this is in fact WebSocket. So to do the exploitation for this, you can use the exploit script provided with the exercise. So when you run it, it will connect to this endpoint, doing the request to the help check with host docker compose internal port 8888, and it will then do a second request to an endpoint that was in fact blocked. So the /env is a path from Spring Actuator. So yeah, if we go to env or trace, we'll see that there are plenty of paths that have been blocked. But here with our exploit, we do first the request that will return the switch protocol status code, and then the request that will follow, it need to be in the same TCP socket, and this is what the exploit script is doing. Then the request to env will return the proper request, so we can now access any path on the backend application. So you can go along and continue to fetch other paths from this application by modifying the exploit script. You can fetch trace and other debug path from actuator. In the next scenario, we'll see something similar, but with HTTP2 cleartext, which is another protocol. Maybe one last thing that I can add, in this scenario, the proxy was Nginx forwarding to a PHP application, but there are some vulnerable proxy that were actually transparently forwarding content for WebSocket regardless of the status code. So old version of Varnish were affected by this, so you didn't need to find an endpoint that was reflecting status code 101. This is specifically for the scenario of this workshop, but be aware that many proxies are available to this, but these are for most part old version of proxy.